Hello, this I think is the third session on quadrilaterals. In the previous two sessions, we had discussed the angle sum property as well as few theorems taken on parallelograms. I think three or four theorems on the parallelograms. Herein we continue with some more proofs on parallelograms. The next question I write down, it says, in a parallelogram, the bisectors of any two consecutive angles intersect at right angle. To do so, let's draw a parallelogram here and name it. We have been doing it as A, B, C and D. Bisectors of any two consecutive angles. Let us draw the bisector of angle A. I'll make the bisector of angle B meet it at this point which we name as O. We have to show that this angle AOB is right angle. So let's write what is given to us. We are given that ABCD is a parallelogram. I'm using the short form of writing a parallelogram, and AO and BO are bisectors of angle A and angle B respectively. To prove, we say angle AOB to be 90 degrees. Since ABCD is given to be a parallelogram, I start writing the proof here. This angle 1 I'll take and this to be angle 2 I take. As because this is a parallelogram, AD will be parallel to BC. Thereby making angle A, I write, as because AD is parallel to line BC, angle A plus angle B, that is the angle on the same side of transversal, interior angle on the same side of transversal, they are supplementary, and that makes it 180 degrees. So now in triangle AOB, angle 1 plus angle 2 plus angle AOB is 180 degree. That's the angle sum property of a triangle. Now angle 1 can be written as half of angle A plus half of angle B. 2 can be written as like that, plus angle AOB is 180 degree. Now here if I continue, I divide the whole equation by 2, thereby making it half of angle A plus half of angle B will be half of 180, that makes it 90 degrees. And I substitute this equation in equation 1 in equation 2. Substituting, okay. So half of angle A plus half of angle B can be written as 90 plus angle AOB is 180 degrees. So angle AOB becomes 180 degrees minus 90, that makes it 90 degrees. So when the bisector of two consecutive angles intersect at a point, that is a right angle. Let's move on with another proof. I write down the proof to be taken. The angle bisectors of a parallelogram form a rectangle. Oh, I didn't leave any space. That didn't. So when I have rectified it, I have made it. The angle bisectors of a parallelogram form a rectangle. Again, we need to draw a parallelogram to do so. I draw a bigger parallelogram this time. I hope it looks like one. Yeah. Let me name it again as A, B, C, D. We have to draw the bisectors of all the angles. Yes, these will all be kind of imaginary bisectors. I just took a couple of minutes to figure it out. We have to prove this one within to be a rectangle. To do so, let me name them. P, this is Q, this is R, and this to be S. We have to prove P, Q, R, S to be a rectangle. So let's write what is given to us. Given is a B, C, D is a parallelogram. It also says AP, B, AP, we are making them meet. So P, Q, R, S are all the bisectors. B, P, C, R, A, P, B, Q, A, P, B, Q, AP and BP, AP, BP, then CR and DR are bisectors. Oh, I'm making few mistakes in the spelling here. This I kindly ignore them when I'm writing. And CR and DR are bisectors of the angles. We have to prove here that PQRS is a rectangle. If we can prove first, what do we do here? I start writing the proof part here. As because ABCD is a parallelogram, we will know that AD is parallel to BC. If in that case, if AB is suppose working as a transversal, then angle A plus whole of angle A plus whole of angle B will be 180 interior angles on the same side of transversal. So half of angle A plus half of angle B will be 1 by 280. That makes it a 90 degrees. This also, we had done in the previous question as well. Now half of angle A is angle angle B AS, this one, plus half of angle B is this one, that is angle A B P. No, I made a mistake here. BAP and ABP, and that makes it 90 degrees. This is one equation. Now in triangle ABP, in triangle ABP, this angle which I had marked as angle BAP plus angle ABP plus angle this one I mean, that is APB, that makes a triangle, so that is equal to 180 degrees, right? So this we can substitute as 90 plus angle APB as 180 degrees. So angle APB is 180 minus 90, that is 90 degrees. This angle I have now proved to be 90. I'll mark it as 90 degrees. This to be 90 degrees. So we can do the same thing, the same method in the opposite side and take triangle DRS. So in triangle DRS also you can check follow the same way of proving what we did in triangle APB. We do the same thing in DRS and prove angle R to be not angle whole of angle R, we'll take it as angle DRC to be 90 degrees, right? Now these two are 90 degrees. We can also take triangle, we now take one of these ASD. Now in triangle ASD, if you see with the same process you will able to be proving angle ASD to be 90 degrees. That means you make first this with following the same proving the taking up this angle sum property of a triangle, taking the angle bisectors, making angle ASD to be 90. If you prove angle ASD to be 90, automatically angle PSR becomes 90 because they are vertically opposite angles, right? You do the same thing in triangle BQC. You will prove angle BQC to be 90 degrees and the vertically opposite angle on the other side becomes PQR to be 90 degrees. So thereby making all these angles, the interior angles in angle PQRS to be 90 degree, thereby making PQRS to be a rectangle. In that case it won't be a difficult proof for all this rest of the three which I didn't do in detail, but they'll all follow the first part which we have done here, thereby making PQRS all 90 degrees, the interior angles of PQRS, thereby making PQRS a rectangle. Hope you followed it well. Thank you.